Welcome back. In this video, we will be talking about systems of linear equation. Let's start with the concept. We want to know what is a system of linear equation. So when we are talking about a system of linear equations, we just mean like having two or more set line equations, right? When we are dealing with only two variables like x and y, the graph of a system of linear equation or two equations would be a pair of lines in the xy plane. So there would be three possibilities. When we have, let's assume these are our two lines, okay? Two straight lines, okay? When the two lines intersect at exactly one point, right? We solve the system of linear equation to find the intersection point, which is exactly this here. And the two lines can only intersect at one point, okay? So the other one would be when the two lines are exactly parallel. When they are parallel, that means there is no intersection point. They intersect at 0 point, okay? And the third possibility would be that they are exactly the same line superimposed. So there are infinite number of points. These are the three conditions that hang. These are actually the three possibilities that can happen. But let's see how we can solve a system of linear equation. Okay, so there are four different methods to solve a system of linear equation. The first one would be the graphing method. In this method, what we do, we actually graph the two methods on the xy plane, and we would see that where they intersect. The second method which we can use to solve the system of linear equation is substitution method. Remember, we have two variables, x and y. So first we can solve one linear equation, let's say for y in terms of x. Then we substitute that expression for y in the other linear equation. Then we would have one expression or one equation in terms of x. Then this we will solve it, and it gives us the x coordinate of where the intersection happens, right? After that, we can plug it in to either of the equations, the original equation, and it gives us the y coordinate. So we will do an example on each of these, but right now I just want to explain the concept behind each of these methods. So the third one would be linear combination method, which some people, they just call it the addition method or elimination method. They all refer to the same thing. What we will do, we add or subtract or multiply one of the we actually, here, the purpose is to eliminate one of the variables. Okay, so in order to, what happens is we just want to make sure that one of the variables, let's say x or y, are equal but different signs. So when we add them together, they would be eliminated. And then we would have an equation in terms of one variable, we solve it, and then we get the value for one of the coordinates and we plug it in into the other one and get the other value. The fourth method, which we also, there is a separate chapter, it would be the matrix method or Cramer's rule, and relatively easy. And remember, the answer you get through any of these methods would be exactly the same as the other one. Okay? If the question doesn't specify which method to use, you can use any of these. unless they ask you specifically to use one of these methods. Okay, now let's do one practice question on each of these methods. So for graphing method, I have two lines. One of them is 0.5x plus 2, and the other line is negative 2x minus 3. So I have two equations, okay, line number 1, line number 2, and each of these lines have got x as y and y as their variable. So in the graphing method, what I will do, I will graph this line separately and this line as well, and see where they intersect. So I would have my Cartesian plane, which is xy. It's two-dimensional, right? So let's graph the first one. Okay, let's start with line number 1. I call this one line number 1. I call this one line number 2. So in the first one, I give x as 0. The y would be 2. The second one, I get x as 2. So that would be, y would be 3. Okay, now let's draw the line. So it would be 0 and 2. Okay, 0 and 2. And the other one would be 2, and the y value is 3. So this is the line, okay? So this is the first line actually. Okay, this is the first line. And now let's graph the second line. Right, I go x and y. Now consider the second line. Again, I gave x as 0, y as negative 3, x as 1. So I give it negative 1. So this would be 2. 2 minus 3, it's negative 1. Okay. And now let's draw the line. So it would be 0 and negative 3, 1, 2, 3. Okay. The other one would be negative 1 and negative 1. Okay. And then when I cross the line, when I pass the line from these 2 points, let's see what happens. And then here I have this one. So you can see, because remember, as I just mentioned in the previous video, you can extend the line from both sides indefinitely. So there would be an extension point. This is an intersection point. This is the intersection point. Okay. Then you can find, if you use an engineering paper, then you can easily find the x and y coordinates of the intersection point. Okay. This is method 1. Method 1, if you want to get the exact values, you should definitely be very precise and use the engineering paper. Now let's move on to the second method, which is called the substitution method, right? This one, you solve the system of linear equation through algebra. So what you will do, as I just mentioned, you will write one of the equations, one of y in terms of x or x in terms of y, substitute it in the second equation and then solve it. You get one of the coordinates and then substitute it back. So let me give you an example here. Maybe by example it would be easier to comprehend. So 3x plus 2y equals 16. That's one equation. The other equation would be 7x, okay, plus y equals to 19. So again, I have two equations. Both of them are in terms of x and y. I have two variables, x and y, okay? Equation number 1, equation number 2. So this is line number 1, this is line number 2, and I want to see what is, if they intersect, right? What is the coordinate of this intersection point, okay? So what I have to do in this method, I will take one of the equation and I try to solve one linear equation for y in terms of x. So here, what I take a look at these two equations. I pick this one and try to rearrange it. So y would be equal to 19 minus 7x, right? Y equals to 19 minus 7x. Now what I can do, remember, this is equation number 2, this is equation number 1. Now what I'll do, I just substitute y in equation number 1. Okay, and let's see what happens. So I have 3 times x, okay, 3 times x plus 2 times y. But instead of y, I use 19 minus 7x, and then it equals to 16. All right. And now let's add or subtract the like terms and simplify it. So I have 3x here and 38 here, and then minus 14x equals to 16. So if I move around everything, I will have 3x here, negative 14, so that would be negative 11x. So 38 here, I move it to the other side, plus 16, that would be 22. So it's a linear equation. If I solve it, actually, if I move it to the other side, it would be negative 22. So from here, x is equal to 2. Now, I found the x coordinate of the intersection point. Now, what I have to do, I have to plug in this value into either of these equations, either of these. It doesn't make any difference to find the y coordinate. So what I will do, I will plug it in. Let's say I use equation 2. Okay, equation 2. I plug it in into equation 2. So wherever I see x, I substitute it with a 2. So that would be 7 times 2, which is 14, plus y is equal to 19. So the final answer for y would be 5. So the intersection point would be the x coordinate is 2, the y coordinate is 5. And let me write it down, intersection point. Okay, this is the intersection point, 2 and 5. The third method is the linear combination method, which, as I mentioned, it has 2 other names, addition method or elimination method. What we have to do, we have to add or subtract. It doesn't make any difference. A multiple of one of the equation to the other one, so that either x term or the y term is cancelled out, right? So we would have an equation in terms of only one variable. We solve for it, we get the value and substitute it back to get the other coordinate. So linear combination method, let's move on to a new page. Okay, let's remember this is the linear combination method. And we want to solve an equation using this method. So it's 4x plus 3y, 4x plus 3y, it's equal to negative 2. And then there is another one, 8x minus 2y, which is equal to 12. Again, we have 2 equations, 2 lines, 2 equations of 2 lines, right? And we want to solve them using this method. So here the x coefficient is 4, here it's 8. So if I add them or subtract them, they wouldn't cancel out. Here the y is 3, it's negative 2, so it doesn't work either. But if you look closely, if I multiply the top equation by negative 2, let's see what happens. Okay, so I multiply the top equation only by negative 2. then it turns into, and remember, when you're multiplying by a number or dividing by a number, whatever you're doing to an equation, you should do exactly the same thing to the both side of equation. So this will turn into 8x plus 6y equals to negative 4, and it's negative, so it's plus 4, and then I have 8x minus 2y, it's equal to 12, right? Now I have two equations. If you take a look at here, let's say at x, the coefficient here is negative 8, it's 8. So if I add them together, what happens is they will cancel out each other. So now I try to add these two equations to each other. This will cancel out with this one. Negative 6y minus 2y, it's minus 8y, and here I have 16. So the y, if I solve for y, the y value would be negative 2. What I can do here, I can plug it in into either of these and find the x coordinate. So this time I just plug it in the first one, so 4 times x plus 3 times y equals to negative 2. This is a linear equation, so 4x minus 6 moves to the other side, the sign flips. That would be 6 minus 2, which is 4, so the x is 1. So as you can see here, the intersection point, which for initial I just put interpoint, is equal to 1 and negative 2. That means if we graph these two lines precisely, the intersection point would be exactly occurring at 1 and negative 2. Okay, as I just mentioned, the fourth method, which is like the matrix method and matrix method or the Cramer's rule, it's a very this method, it's very new to most people. I would say not very common, because working with matrices greater than 2 by 2, it's very difficult. I have explained this method in another video. I have allocated one whole video to this topic. I will put down the link in the comments so you can watch that one. In the rest of the video, I will try to solve a couple of examples